Well, hi, good morning. Thanks so much for joining me here in my shop for another round with this radio. Yesterday I replaced a couple capacitors in it in the front end. I really didn't expect anything to change, but its performance changed entirely after that. And it's turned into a bit of a monster here. So I spent my day yesterday thinking more about this. Let me just go over the symptoms here. I expected the radio to work pretty ordinarily, but instead, when I tune the radio, here's what I got. Silence. Now either at this point an oscillation is occurring, and what it's done is it's producing a signal through the IF. It's being rectified in the detector, and that's generating an AVC voltage which has quieted the radio right down. And that's why it went silent. Or the oscillation's over here. Let me tune back. And this is the point where there's an oscillation. Another thing I noticed, and I'm not sure what the answer is to that. I have ideas in my head, but another thing I noticed is when I do tune past a station, and I don't have an antenna connected right now, there's always a heterodyne tone coming through with the station. I think that's a big hint as to what's going on. But the strangest thing of all is, this is the volume control. It's hard to perceive, but I think the oscillation is quitting or starting, whichever way it is. Right there. Sounds like a cold, windy night. So that has a characteristic sound too. It sounds a little like, a sound conveyed down a tube. It has that kind of sound to it. So putting all this together, it really hasn't come together in my head, but a few observations I can make here. The sound itself is very reminiscent of a highly, an IF with a high Q. That's what it sounds like to me. It sounds like you're moving through the tuned portion of the IF. I have radios with, I have some old military radios that actually have this kind of sound in them all the time as you tune through stations. They kind of have that well, that makes me feel cold. So I think it's an IF thing. Come around to another part of the observation here, which is the heterodyne tone I can't demonstrate at the moment. As you tune through received signals coming in on the antenna, there's a heterodyne tone. That to me suggests that the IF is oscillating away at 460 kilohertz, whatever it's tuned to. It's become so sharp, I guess maybe would be the word, so sensitive that in fact it is oscillating itself. Somehow the output of the IF is making it back to the input. It's coming through again, and of course what do you get there? You get an oscillation. That's why as you tune a station and the station's carrier frequency approaches the IF frequency after being converted, it's actually approaching a tone. There's a signal in the IF at 460 now. It shouldn't be there. And as this comes along close to the thing you're tuning, as you tune the local oscillator, it moves the antenna, the converted antenna signal you're aimed for, closer and closer to this oscillation that's taking place. Once you get close enough, you start to hear the heterodyne, maybe 5,000 hertz, 4,000 hertz, whatever it is. Only I can't whistle. That shouldn't be a swooshy sound. That should be a tone, whistle. I can't whistle like that. So that's what I think is going on. I think basically the IF is so hot at this point for some reason that it's breaking into its own oscillation, which we cannot hear the actual 460 hertz oscillation. We could see it. We could see it if I took the time to try to do that. I'm really interested in this problem because I think I'm basically have an opportunity here to learn a lot. And I don't want to just flick something and the problem goes away, and I never really understand what the heck happened. I have another radio that I had in here a couple of years ago, and I shotgunned. It's a small 5-tube radio. I shotgunned the capacitor, which I don't normally do, but I thought, what the heck? When I got it all done, the radio squeals like a son of a gun. I call it the squealer. Maybe one or two of you, maybe you might remember that radio. I've had it in my shop since then a couple times to try to de-squeal it, and I haven't been successful. So I know there's some stuff there. I obviously have a hole in my understanding of this kind of thing. So, typically oscillations in a radio are snuffed out by all these capacitors that you see going to ground, things like this one. So as long as these guys are doing their job, there shouldn't be any opportunity for the output to work its way back to the input. Shouldn't be. Now this is where component positioning may be really, really critical. Now, I moved a few components around when I reinstalled them. I picked different grounding points and swung the component way over to a different position. I don't think any of that. I did all that down to, I'm indicating the audio area. Up in the RF area, I've only replaced a couple capacitors, and they're in exactly the same position they were in, the new ones. So another possibility is, because the new capacitors, like this one, you can't tell which one's the outside foil. They don't mark it anymore. On the old capacitors, right, they have the old outside foil mark. So you can arrange this to make sure this terminal is tied, in many cases, tied to ground or the chassis or something like that. If you do it the other way around, the capacitor becomes a bit of an antenna. Now what's it going to pick up? It may pick up the signals that are traveling in the radio, like the local oscillator may get picked up. Powerful signals coming out of the end of the IF can get picked up and shoved back through. Something like this is going on, I think. I just am talking about it here. I think really, and the next thing to do is to try to examine the. I'll get this on some kind of spectrum analyzer, and we'll see if we can't kind of sort out where. Sort it out. Let's just sort it out. I kind of sort myself out. Where's my coffee? And just before I do that, in order to totally distract from what I'm doing, one of my favorite hobbies is being distracted. I think I mentioned a video or two ago, I'm fighting the flea fight in the house here with my two cats. We've won the fight. The powerful insecticide, typical routine insecticide people use on their pets, nothing special here. Threw it on my cats. Fleas dead. 24 hours later, all flea activity almost to zero. Almost to zero. Fantastic. But guess what I have? I managed to get one. As one of you suggested, I stick it under my microscope. Okay, if you don't want to look away. Look away. Because there's a flea out of my house under my microscope there. Look at that ugly thing. Now this flea is so tiny. It is so tiny. This is not a big flea. This would be a very young flea. Isn't that just the creepiest thing? Now you've probably seen pictures of fleas before. But and he's pretty sure to be dead. He hasn't moved now in 24 hours. So that's what the flea insecticide does. It kills them. So there we are. Enough flea stuff. Anyway, for you who asked me to do that, there you are. Now let's get back to the radio stuff here. Okay, so up on the screen I've got my SDR radio running, and it's connected to just this loop here. There we go. I'm just going to kind of push this around the radio a bit and see what shows up. Now, if there is, let's think about this. If there's an oscillation in the IF, it's going to be 460. It's going to be right around where the IF is tuned. So now the SDR is showing 3 megahertz. Let's get way down to Okay, so this is as low as, I think this is as low as it'll go. No, a little bit lower. That's okay. So we're going to stick it here. So 455 is right in this area. Oh, look at what is going on there. What is that weird thing? The radio is currently tuned to around 1100. So the local oscillator should be running around 1450, 1500. So that's certainly not where we see that weird thing there. Okay, I have no idea what that is on the screen yet. And I'm talking about the thing at 1200 kilohertz there. So I'm going to tune the radio. We'll just watch what happens. The local, this oscillation I assume is in here may be way higher frequency. It may be way off the screen. I don't know. We're going to hunt it down though. So first I'll tune the radio and we'll watch what happens. I better turn it up here. Oh, even that. What are we looking at here? Wait a minute. This is just laying on my bench. What is that thing? Oh, this is off to a bad start. Some artifact of the SDR radio itself. It does not want to go away. I'm going to tune. The SDR tuning point is this red line. I'm going to move it right here. I'm going to listen to it. Oh, what happened? It just got bigger. I have no idea what that is, and I've never seen that before. Let me cut the power to the radio. Okay. Let's see, my signal generators. The radio hasn't come back exactly the same, has it? Maybe on the edge of the oscillation, and turning it on and off has simply flipped it. We gotta get a much better signal going here. I have a better idea than that silly coil. Just a second. How I arrange my leads, they get all tangled up. Okay, so this we're going to use as our sniffer coil. As soon as I plug it in, much better than that silly loop of wire I had there. Okay. Okay, this is active. So I'm just going to poke around these coils and look for a strong signal to show up. Wow, there's not much showing up, is there? It's impossible the local oscillator is failing to oscillate, and that's what we're hearing. We're hearing the local oscillator. There's nothing. Nothing too exciting there. Okay, let's tune the radio a bit. Got a coil, coil, coil. Oh my gosh, doesn't that suggest something right there? What coil is that? Is that the oscillator coil? What coil is that? How can I find out? I really can't find out. Oh, wait a minute. Here's the adjustment. There's some big warnings about these two adjustments in the manual, which are complicated things I won't go into right now. So this is actually this way. This is kind of lining up with it. 700 kilocycle auto tuning antenna coil trimmer. So auto tuning is the word they use for the push buttons here. So you wouldn't quite think of that as automatic today, but some pretty strong warnings in here. These two guys are factory adjusted, and it's to compensate for wiring in the radio. So after the radio's built, the wires are just a little bit different position, different capacitances in there, whatever it is. These things compensate for it. In the manual it says, these are adjusted in the factory, should never need adjustment again. Oh yeah? So this one has no core to adjust. This one has a core that can be adjusted, like this one. These two are appearing above here. It's saying there's a third one. Core. Condenser. It says there. Oh yeah, there it is. It's hard to see. So it's coil and capacitor, coil. So that's this. This guy is out here, you know, is not adjustable. Well, how can it be factory adjusted? There's a trimmer capacitor somewhere that works against this. Somewhere in here. Auto tuning antenna coil trimmer. So we're looking down from the top. Let's look down from the top here. Swing this guy around carefully. Okay. So these three things are way up here. This is it here. Looks like it's got a locking thing. Adjust it from here. So they must have a moving core inside these two trimmers. Is that what's happened? I've changed some parts. It's set up a situation inside this radio that is compensated for by these two controls, which are no longer compensating for it. Is that what's happened? Okay, back to seeing what's going on here. What is going on? I should be able to get the oscillator to show up nice and clearly here. Let's go back underneath here. Back. Roughing up my speaker connection there to the meter. Okay, so watching the SDR and looking for something tall to show up. You know, this is set on shortwave. Let's set it on AM radio. What happened there? Oh, it's like a different radio. Oh, there it is. Oh, you can almost hear it break into full oscillation there. So, you know, just to... Yeah, I'm jumping around, but that's okay. Let's jump around some more. What's going on with this volume control? That the volume control can change this this effect. So the volume control is connected onto one of the IF coils here, and we're moving this slider up and down, and pulling out varying amounts of signal through this capacitor onwards. This weird sound we're hearing, this talking through a tube thing, I don't think it can occur out here. I really believe it's happening in here. So that would mean varying the volume control is somehow affecting the tuning of, let's say, this transformer. Is that possible? I suppose it could affect the Q of this, because it's basically a resistor and you're varying it a little bit. I mean, a tiny amount of variation is occurring when you move this control up and down. That's how I would perceive it. Well, you know, there's no denying it. No denying it. Okay, start thinking quietly, and I don't want to do that. I don't want to be thinking. Let's carry on with the alignment. No. We're still hunting down what's going on with it, trying to get a view of it. So we're not getting anywhere with the sniffer coil. Let me change the way this thing's operating here. There we go. Oh, there's something on the SDR. Signal strong enough to produce a red line on the waterfall. I'm going to tune the radio slightly. You'll see if that moves. Yes, it does. It's a little bit of a delay there. Okay, so that's almost certainly the local oscillator will identify the frequency here. Let me move it. Wow, what was that? So in my thinking, what's happening there is we're bringing in an external signal from somewhere. I don't know where. There's no antenna. And we're moving it very close to the oscillation frequency inside the IF. You can hear that's making it move a bit. Okay, I don't want to listen to that. So we're going to move it off a bit. Okay. Now, it should be a certain thing based on where the radio is tuned. The radio is tuned to 850, about 850, just below 900. Let's use 900. 900 plus 460 is 1360. We should see that line around 1300. So, oh, I put this. Where is the line? There it is. Well, 1375. You know, that's close enough for government work. So that's the local oscillator. Why couldn't we see it? Let's tune the radio and watch what happens to it. It's hanging in there. Wow. Let me just go back a bit there. Curious stuff. Well, the local oscillator's not going away, but I haven't heard that weird thing. Let's get the weird thing. Down to the weird thing. It didn't. Oh, there it goes. Okay, the radio's gone silent now. Well, the silence, you know, the local oscillator is not changing at all in terms of strength or frequency or anything as this thing pops in and out of whatever it's popping in and out of. So I don't think this is an effect stemming from the local oscillator in some way. Well, I'm sorry, I have no diagnosis, so I have to order up some more tests. In the meantime, there's a bunch of pills to take. Well, let's go on with the alignment, because I'm not getting anywhere here in terms of cluing in as to what exactly is happening. So, the alignment is, just to show you, so I'm not going to read this, but here's the alignment sheet. There's a table of all the information you need to do the alignment of the two bands in it, and all of this is a discussion around these buttons. This whole thing. Ending with a discussion about the next model up from here. This is a 535. It goes on to the 636. 636, that's the next radio that's coming in my shop. The next model up from this is coming in here. We'll be looking at the same radio. More of these, more bands. So, yeah. And then, you know, I don't know that these two adjustments, these factory adjustments, I'm a little bit worried about whether they can have any influence on this problem. I don't think they can. So I don't think they're really an issue. Has all a lot to do with just these buttons here. Okay, let's do the IF alignment and see if this thing just cleans up. maybe it'll clean up at that point. So you need a 0.01 capacitor stuck onto the grid cap of the 6K7, so we can feed a signal into basically into the second IF transformer, this one here, and tune her up according to my meter, level meter. I'll leave my SDR going up there. And, how about a little volume for this? Finger. A little loud, eh? Okay, a little volume, a little less volume. That's really not on there good enough. Okay, signal generator output. Where are you? Tangle of wires. Generator output. One lead on the ground here. Okay, that's a chassis connection. Another lead on here. Turn this up. What's that tell you? Tells you this is a... First, my signal generator is turned way up. Take it way down. Way down. Take it down, not way down, but down. So I've done two things simultaneously here. That's how smart I am. Hooking this up pushes in a signal and also cuts out the regular signals in the radio, because this is somewhat of a short circuit here. Again, that's probably why you need the capacitor there as required in the instructions, to compensate for the effect of the signal generator low impedance. We're all set. 460. Dial setting should be 1700 and no signal. Well, I can't imagine we're going to hear anything here. Put it up there. Okay, 1700. That's capacitor all the way open. Tuning capacitor all the way open. L2122. Now, something interesting I noticed when I was just fooling around the other day, basically, with some stuff in my shop here, with an IF that I was tuning using the sweep generator, and I discovered that the primary side of the transformer seemed to shift the frequency, seemed to shift the resonance of the transformer, whereas the secondary side just seemed to increase the throughput. Increase and decrease the throughput. I don't know if that's really the case, but if that's true, you really need that firmly lodged in your head. Okay, so we'll get ourselves a little screwdriver here. Okay, sensitivity of a metal screwdriver. So I heard the tick. Do you hear that tick? Let's see if I can replicate it. It's easier to replicate than I thought. I could go into a long and interesting explanation about why touching this makes a click, but I won't. I'm not supposed to be touching that anyway. I'm supposed to be touching this. What just happened there? So in radios and electronic circuits, there's been a number of times, a large number of times, where I've had a piece of equipment operating at, let's say, a certain level, volume or something, and I just touch with something like this onto, say, a capacitor lead or who knows what. There's a little click and the thing comes to life or goes down. And exactly what goes on there, I don't know. I imagine it's some kind of bad capacitor thing. I don't know. I really don't. I just noticed it here. I think. Did I? I don't know. Okay. Fooling around too much. Let's get the signal generator right on 460. Okay, something not right with the meter here. Oh yeah. Okay, so I hear two peaks as I tune through it. I'll tune slowly. I don't know what that was. Two. That's really weird. Tune up this way, I saw one peak. I tune down, I see two. Let's try that again. I'm just seeing things. Tuning up. Up, down, up, down. There we are, two peaks there. So that certainly indicates there's a bit of a misalignment somewhere in the radio, probably the IF. Get this on 460 now. Okay, that's 460. Counter's a little off. See, the meter is jumping around a bit. That's not too helpful. Hold still. Oh, you know what? I was going to say, I don't know if I'm doing the primary or the secondary. No, it's written in here. It's written in here. Secondary adjust screw on top, primary adjust screw on the bottom. It says right here in a note. Excellent. Let's start on the bottom. Oh. Okay. It's a little busy under there. Sure, right there. Oh my gosh. Okay, I see it. No, I don't. Oh boy. Okay, so getting the screwdriver into the slot on the threaded slug shaft is going to make me bump into the end of a dog bone resistor. Dog bone resistor. And what that says to me is I could short something out. Okay, so I have a sleeved screwdriver, but I think the blade is too big. Let me check it up here. Okay, so I have another sleeved screwdriver. Where are you? Of course, it's the one you need you can't find. It's always the way it works. Okay. I'll sleeve this one. Chances are touching the end of the dog bone resistor won't matter. But I don't know what's on that resistor. I don't know how much voltage is there. A little more. And I don't want to move that resistor. That's another option. I don't want to be pushing that around. Okay, here we go. Going in. And we're in. Okay. Now the objective of the exercise is to make that meter go up. Well, this is easy. This is a mile out of alignment. So I was saying to perhaps the radio. I'm going to turn down the volume here. Perhaps the radio is oscillating because the IF is so sharp. Well, I don't think it's so sharp. Now we'll do the secondary side. Just get the screwdriver to go in. There we are. Okay, watching the meter behind my hand here. I'm not going to do this. Oh. Okay, ready? Oh. What's it doing there? So I think I'm just past the peak. But, other factors are moving that meter around. Oh, back. Jeepers creepers. Okay, bottom again. Or I should say, primary side. Hold still, radio. Down, up and down. That would be it. Okay, so that's one IF done. Now I wonder what's happened to the radio. Turn down the volume here just in case. Take that off. Take that off. Leave that there. Let's turn it up. Well, that didn't change anything, did it? Okay. Next IF. Basically do the same thing with the signal injected in a different spot in the radio. 6K8 doesn't actually say where to hook it, but I'm going to assume it's right on the grid cap again. Volume down. Hand behind my back. Oh, that was nice. Signal generator. Turn down the level on the generator so it's 1/10 what it was into the other two. Hook it up. Hook it up. And we should hear it. We hear it, but yeah, that's good. Now I've got such a low signal coming in here. Hopefully the AVC voltage is not developing. There's no AVC voltage developing. Do the primary on this one on the bottom first. This one is pretty much in the open here. Okay, there we go. Watching the meter. Oh, the sound just disappeared. Oh, listen to that sound. What's that sound like? Hey! Definitely oscillations happening. What do you make of this? Let's just follow the procedure and see if they go away. Never had a radio do this. Exactly this. That jumping is the metal of the screwdriver touching and detouching the metal rod. Very, very sensitive. Stopped. Started. Volume down a little bit she's a singing now. Let's keep going on this. It is so sensitive. So I'm trying to make the fantastic. Let's do the top one now. This is a mess. Hold still. Oh, what happened there? It all went away. What happened? I gave it a real good shot from... I touched this. Hey. What was that? Maybe 2-pin cap contact. I don't know. For what it's worth, I can hardly turn this one. I think we found the source of the oscillations though. Going down, going up, going back. I know for sure I do not have a plastic tool that can turn this screw. The screw is so hard to turn. Only a metal one's going to do it. So let's see, what's going on here? Adding this in makes the tone go low. I'm going to take that back. Maybe I do have one that's strong enough. We'll see. Okay, so these plastic things are almost impossible to do an alignment with. No, I can't do it. I need the leverage of the handle. So if I turn this to get a maximum reading on the meter, I can just, okay, watch. There. Okay, that's about the peak. Now if I go a little further, come back. I'll take the screwdriver out and it all goes south. So I can't leave the screwdriver in there forever. So we're going to turn this down. Take it out. There we are. So, yeah, does this fix this oscillation? Geez, I don't know. I don't think so. Change the volume. Hey, it's no longer... it's just volume now. It's no longer doing that... I don't know what to call it. Bandwidth change. That's interesting. Tune the radio around. Wow, this thing really wants to pick stuff up. Let's give it a chance. Volume down. So all we've done is adjust the IF. Oh, these are the worst clips. Okay, so we want to put a real antenna on this. I think I have to run through my house again. Turn the switch. Let's put this on and see what happens with just this piece of wire to nowhere. I'm going to clip it back here. It's just a little more solid. Clip. Okay, so we're hooked up to an outdoor antenna now. Let's see what happens here. Oh, it's back to that. It's back to that. Phooey. Okay, let's keep going. Still got the tone. The heterodyne. So the heterodyne tone is here now. That means the oscillation, I assume, is in this radio is happening right now. Can't say it ever stopped. Let's go down here. Well, it seems as if whatever's going on in the radio now doesn't change state. It used to be 2 states before. Tune at a certain distance to be in. So now we're down to 1 state. It doesn't seem like a very good state to be in. Well, I hate to suggest this. Did I make a component change error earlier on? And I just didn't detect the consequences of my error. And now that's what we're hearing is the consequences of a component placement error. That's a headache. What other adjustments could affect this kind of thing? Because is the radio actually pick anything up? So we're down. It's gone kind of quiet, but we're down in the range of where stations are to be heard. Are you hearing what I'm hearing there? If I go back a bit, the swoosh will come in. There. I go forward. Swoosh goes out. What has gone wrong with this radio? And it's well, well, we got the IF aligned. We know the IF is in the right frequency and is sharpened up now. So that can't be a problem in itself. I'm going to have to examine all these components I put in and verify that, especially the ones that are in the IF area here, there's only 1 or 2, frankly, and see if I didn't make some dumb mistake here. Okay, I'm going to have to do that. So I've just been checking through the different capacitors I've installed and haven't found anything interesting when it suddenly dawned on me that I have this big cable sticking out here. They used to go to 3 phono plugs, and there's a switch here that is somehow involved with it, which I think is either, phono input, something like that. But I have not really investigated this. The end of it's just kind of ripped off and hanging there. For all I know, there's shorts in there. I don't know. Why did the radio just go quiet? Okay, so that's the next topic for sure. What is this? Is this something somebody added into this radio? And I think there's a real good chance it is. Well, it'd be quite a task to do that. And there's some evidence of it. Okay, let me get my close-up camera going here. Where is it? Oh, I know where it is. It's over here, looking at the flea. Okay, away from the flea. So here's the guy here. I think this is... it looks pretty clear to be just 2 cables, and you can almost see there's a short, potential short right here. The other one, the center conductor is quite clear of the shield. So that's all that's going on here is 2 wires. And down here, if you can see this, you see the switch, the toggle switch. That's the wrong vintage toggle switch. And it comes into this taped bundle. Nobody would do this in a factory. This would never be done like this in a factory setting. And then these 2 cables, let's go up to the top again. So like a steel braided shield on it, quite distinct, and down here are 2 steel braided shielded wires. Now here's where things get interesting. Okay, they go down in there. I think I got this radio on. The radio's still on here. I gotta be a little careful. So right where you see the shielded wire, let me just put this here. Okay, dead center of the screen there. That shield, it's going underneath the metal bracket. See, it's not shaped properly. It's been manipulated. I think if we look at that from under here, I think we're going to see the solder on it. Okay, so I'm sorry, it's out of focus here. Still see that? What's going on there? That's 2 different kinds of wire. See, the shielding, the original shielding is this wire, like a spring, like a wire just wrapped around it. It's not braided. But up here, they're braided. And right there is a joint between the braiding and the wire. It doesn't look so healthy either, does it? So that's screaming out to me. Somebody did that. That's not factory work. Somebody put a shielded extension on there, brought the shielded extension, like shoved it in here. Look, there's another shielded wire. So now there's 2 of them traveling together, braided. Up they come into this bundle with a switch. So what's he done is he's tapped the audio out. The switch selects between phono in and radio. But these wires are open out here. Okay, so if we follow the wire back, again, remember this radio's operating. The shield's pulled back quite a ways there, right? On the lower one. But look how its shield is soldered to the chassis. That's factory work. Okay, now the other one, look, it's been lifted off its solder point. You can see a solder point on the chassis, and then you can see the solder on the wire, but the 2 of them are not together. So he lifted that. He lifted that for some reason. So it looks like it was probably soldered down there too. if you know where I mean. I'm telling you, in the dead center of the screen now, there's a blob of solder on the chassis and nothing in it. And that's right where that solder is on the wire. So this wire was shield soldered to the chassis. Somebody lifted it and it's floating. They made that joint there. Who knows if that's actually the shield joint, if that's really effective. And then it comes in. Wow, okay. Let's see, a little more light in there. Okay, where'd it go? Okay, so we're following along. Just above that bright, no, just below that bright orange resistor down there. You can kind of get a glimpse of it. Coming around, I can just barely see it. Coming around, soldered to the chassis, just behind the old capacitor lead. So I think I can see that here. Yeah, there it is. Now that looks like factory work to me for sure. And look how many times they've soldered this thing. They're soldering it every couple inches. Wait a minute, where's it going? It's going out. It's a little hard to see here. It's going through the chassis and arriving right. So it's either getting onto the slider part of the. Really hard to tell there, isn't it? Let me apply my own personal eyeballs here. Whenever it's on. I don't feel any shielding on this wire. Remember, the radio's on. Here. I don't feel any shielding down there either. Oh, wait, I see it. Okay, I can see it. It's there. Coming through the hole, coming up to the end of the volume control. Well, that should be easy to spot on the schematic now. Okay, so is this the cause of all the problems that we're having here? Turning the volume control affects the strange thing. These wires are going to and from the volume control, where the strange thing is happening. Now, if they didn't go all the way up to here originally, and these are new extensions, where did they go? Oh, I can look on the schematic at this point. So a lot of schematics, they will indicate where wires are shielded. So here's the volume control. You can kind of guess that this wire would be shielded in here. The reason is that any signals on this piece of stuff here, any signals getting in here, are going to get on the grid of the first amplifier tube. So even a little bit of trouble here is going to make big trouble coming out of the speaker. So they use a shielded wire here. It just goes to the volume control. Okay, so it comes from the volume control. We can take it that way. Because I see where it's connected here, and it goes to, here's where it bing, goes shooting out of the radio. And somehow it's got to get back to here. Where's this point? What's coming off of this point? So this is second IF. Okay, let's take a look. Okay, so the second IF, oh, you know, that's just where those, see the shielded wire there is actually heading straight for the IF. Okay, so the IF, if you look, just above the orange resistor is the slot of the adjusting slug. Now I was scared. Oh, what just happened? I don't know. The thing about this camera I'm holding is that there are grounded surfaces. There's a little microphone grill on this camera. If I put my finger on it, I am actually grounded, hydro grounded at that point. How's that for dangerous? Found that out the hard way quite a while ago. So it could, I don't know. Maybe it's nothing. Maybe you heard a blast on the video. What I'm mumbling about is I touched the camera against the chassis of the radio and I heard a funny sound. Yeah, you may have heard a blast. Okay, get back to what we're doing. So Look, is that the remnants of it down there? I think that is the remnants of the original wire, where he reached down and just cut it. And then the end of it is there. So he cut it, he lifted it up, he couldn't get enough on it, he couldn't get his hands on it enough, because it's really in an ugly, ugly spot in this radio. So he unsoldered it here to lift it and get his hands on it and make that attachment. Because the owner said, can you make this work with a phono? And he begrudgingly went ahead and did it. So that means the audio would come all the way up to here, where a switch would select between phono and alternately continuing the radio output back down the other wire. The other wire. So the other wire is going to connect where the first one is cut away from. So we see the cut away one down there. Wow, what is going on in there? There's a lot of freaking stuff in there. What is that? So what I'm looking at, again, I can't quite get it dead center of the. If you look at the orange resistor, and then there's a wire butted up, appears to be butted up against the end of the resistor. You go a little further left, you see something there. It really looks like an open air capacitor to me. That's a strange looking beast. That's a really strange looking beast. Looks like one end of it is on the chassis. I'm checking for parallax. You know what? It's not on the chassis. It's floating above the chassis. I don't know. You're probably not looking at exactly what I'm looking at now. So I'm looking below that resistor with the yellow band. Straight below the yellow band, you see a piece of metal. It looks like it wants to be soldered to the chassis. It looks like it isn't. And that's right in the business area of the end of the shielded wire, which has been brought back from this botched up job up here. So well, wait a minute now. I mean, if these wires are open, then how is the radio signal making it to the amplifier? Because apparently it's traveling along this shielded wire. I know you're maybe not sure what I'm looking at. Is it spliced in there? What's going on there? No, one wire, the return wire, is coming over the top of the sending wire from the volume control. The sending wire just continues on up. So is the sound accidentally making it through here somehow? It's the switch, Jim. It's the switch. It's the switch. The switch. The switch. It's the switch. The switch is set right now to join those two wire conductors. Oh my God. Slipping out of the shield in here. So you would have had to get the conductor out of the shield of the two wires and then reshield them somehow, and then take the son of a gun up to the point where someone like me will never know the botched up mess that he made under there. My solution is remove all this. Get rid of all this, the switch, all this goes, everything goes back to the way it was originally, which means getting in underneath here, yikes, and trying to work in there. I got these jail cell bars to try to work through. Oh, that explains even more. That explains what this tape is. This tape and this tape are trying to hold these in place, because while he was working, he knocked these around, trying to work down in there. Because there's a bit of a clear entrance through here, which you could apply tool pressure to these two things easily, this one in particular, and kind of knock it off. Now, what if I were to try to remove these tubes? They look like they're just slid in there. Any loose? That's loose. That's not. So, you know, I'm probably imitating exactly what the last guy did. Now, he probably slid this out. And there you are. Now you got some working space. Now you could take that tape off there and slide this thing right out of here. How about this one? Can we do the same with this one? It's pretty solid. So the purpose of these tubes is simply screwdriver guides. So when you take your screwdriver and you shove it in here, okay, it's guided all the way down to the what? It's got to go down that far. Well, I guess these are in dramatically different positions. And now, since I've looked at these coils so much, let me just explain a little bit about them. So, there's one single slug arrangement in here. There's two slugs, but one slug arrangement. There's two slugs like my fingertips, with a rod in between, a fixed rod. And then they are adjusted by the screw out on the end here. The thing is, both move together. You cannot do this. Now what are they doing? Well, I got this set of coils and this set of coils. One set is a local oscillator coil and the other set is an antenna coil. I don't know which is which. I'm going to guess this is the oscillator, this is the antenna. So the idea is you're tuning both the front end antenna circuit and the local oscillator together with the single slug. The relationship between these two coils has to be exact for this to work, and that's done in the factory. And if you look, you'll see these coils are slightly different positions on these forms. Those have been very carefully moved or placed by the builder, and then they're fixed in place, never to change the positional relationship between this and this. Obviously you can't move these coils, but you can slide this a little bit. Once that's set, then the two slugs, the barbell slug arrangement in here, should work fine over a range of frequencies. There's an awful lot written about this. Another interesting aspect of this radio, I don't know enough about it to explain it, is it uses one style of oscillator in a local oscillator, like a coal pits style. I don't really know, I'm just making that up. I'm not making up the word coal pits, but I'm making up which one it is. So when you depress this button, you're setting the local oscillator to work as a, let's say, coal pits oscillator. But when you use these buttons, it's a different style of oscillator. It's a different kind of circuitry and everything. So there's a lot going on here with these coils. And I'm out here kind of fiddling on the fringes. So that's what I got to do. I gotta go down and restore this to the way it should be, and carry on from there. Because at this point, these ghosts I'm chasing, they could be all because of this weird thing that they've done. I mean, after all, think about it. This shielded wire, which was soldered where? Here, 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 to the chassis is not, and has been extended now, so it's much more of it, and no soldering as far as I know. No soldering to the chassis anywhere on it. And then all the way back again on this other wire. Tell me that's not going to have an influence. If the engineers who designed this felt that shield had to be soldered every couple inches against the chassis, then they probably would have said to whoever did this, don't do that. Or you're going to get a radio that makes funny sounds. That's what I got to do next. Let me turn the power off here before I get myself in trouble. And you hear me singing some strange song. That's great. Okay, I think I got somewhere today. I think I got somewhere. We'll see. Tomorrow I'll make this change. I'll come in here during the day. I'll make this change. Tomorrow we'll play the radio and find out. I promise I won't do it without you. I won't play it without you. Okay, thanks for watching, and see you on the next video.